Hello again, welcome everyone. So today in this tutorial we will learn how to communicate and talk to the external EEPROM, which we have today is the Atmel AT24C256C is the external EEPROM, and also it supports serial communication, 2 wires only, which is integrated circuit or I2C compatible. It has 256 kilobit or 32,768 byte. Okay, it's very excited EEPROM. It supports very wide range of voltages from 1.7 up to 5.5, and also as we say, supports serial interface. And also one important thing that we have to focus here is the write cycles, support 1 million cycles only, which we have to really take care, but not in this tutorial. In the next tutorial I'll talk about how to take care of this number, how to improvise our writing method by using or by simulating the update function that we use for the Arduino internal EEPROM. But for today's tutorial, we will not implement, we just go directly for write and read functions, because we will write the code from scratch. Okay, here's some details. You can go through the data sheet of this chip, is very nice arranged. Okay, so this is the chip. This is 8-pin SOIC. So the first 3 pins is the address pin. Okay, from this address pin you can determine what is the address for this chip, because you can hook more than one chip at the same time at the same bus, and you can alter the address to different addresses, so you can talk to each individual one of them. For me, I hook all these pin to VCC, which give me an address to my chip is 57 in hexadecimal. Ground connect to the ground of the Arduino ground. VCC write protection, I connected to the ground also, so I can access all the data, can read the write, because this is write protection from the EEPROM. And also connect the SCL for the clock, serial clock to the serial clock of the Arduino, SDA to the SDA of the Arduino. Okay, that's all. So now let's go and see how to learn how to talk to this chip. Okay, so I will open new Arduino sketch, but before we go through the tutorial, let's see what we will do in this tutorial. Actually, these days I'm on this chip. Is very exciting project. Is a digital FM radio receiver. It's very nice chipset, and it's happened to be support what they say as a serial also, I2C serial. Okay, this chip, it's required frequencies. No need to have external tuner or what they call like analog tuner. You need to send the frequency the frequencies you want to set the frequency directly from the serial, from any MCU, and all what you need is just to supply VCC, ground, antenna, and take the left and right out from the for the speakers, but for sure you need to amplify the signals. Okay, so from here I will try to write a code to store this, because as you know, for example, when you set your frequency, you find some what they call stations on the radio. We want to store it inside the EEPROM, because if you just store it as a normal integers, inside the RAM of the MCU, for sure, whenever you reset your system, all the data will be gone. So it's better to store it inside the EEPROM so they will be maintained. Okay, so let's dive in. So first of all, okay, let me define or declare my frequencies list. Let's define that my integer, my frequencies, and for sure it's array. Let's say it's array of 10 frequencies, and let me say 132 hertz, 127, 164. What else we have? Let's say 218, 195, for example, 214, 190. What else? 170. Any random? For sure, this shouldn't be random. It should be updated when you scan the stations. Then you store it inside the EEPROM. 170. Let's say 160. 237. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these 10 frequencies. Okay. And now let's display them. Let's print them out. Let's see what we can do. We need the serial. Let's start our serial with baud rate of 9600. Okay. Then let's print them out. Serial dot print line my freak one. Oh, sorry. Frequency is this, and since it's array, so we need to use a loop to scan all the index or all the elements inside the array. So for this I will use for integer I to start, let's say, from 0. And it will be less than 10 because we start from 0, and I++ will be increased by 1. Okay, and here we will print serial dot print what? We will print my frequencies of I. Okay, then serial dot print okay, let's test our code. We go to here, UNO COM6. Okay, upload. You want to save? No. Okay, done compiling, uploading. Good. Okay, done. Okay, so as we can see here, the first step is just to create our frequency list, which is actually an array, and also we display them. Okay, good. Let's move on. So now I need to store them inside the EEPROM. So in order to talk to the EEPROM, for sure we need to use a library called wire to access to the I2C protocols. So we need to include wire, and this one is also already implemented inside the Arduino IDE. And be careful, the W should be the W of wire should be capital. Wire.h. And also one more thing, we need to define the address of the EEPROM. So hash define EEPROM address. For my case is 0x57. Okay, so now let's start with what? Let's say we start with the writing function. Yeah, let's start with how to write data to the EEPROM. So let's do a function here. This is setup loop. For today, we will not use loop function. Most of our code will be in the setup. So now we come here. We say this is writing function to the attached EEPROM. Okay. So for sure, this is a writing function, so we will not return anything. So it will be, for sure, it will be a void because we are not return any code or any data. So void, let's call it EEPROM. We cannot use it, it's a keyword. EEPROM write. Okay. EEPROM write, and what it need. Okay, let's see what we need to store data inside the EEPROM. So for sure, the first thing is we need the address of the device or address of the EEPROM. Okay, so we need the EEPROM address. Okay, this is the first key we need. Okay, EEPROM address, which is here, which is this one. We need to send this address. Now, sorry, what else we need? We need to know the location of the internal address of each cell of the ROM. So we want to store the data in which cell inside the ROM. So this also we need address. And this address, as we say, it's a port 32,000 something. So for sure we cannot use normal integer. So we have to use unsigned integer. We call this let's call it cell address. What else we need? For sure we need the data, but this data for sure just a byte, because as we say, it will store a byte. Okay, so now let's see. In order to talk to the EEPROM, okay, whatever you need to read, write, or anything, even to any other any other I2C device, you need to begin the transmission. Okay, to begin the transmission, we use the command wire dot begin transmission, and then we send the address of the device or the address of the EEPROM, and here we store the address of the EEPROM here in this variable. So we send like this. Okay, so now we start the transmission, or we open the channel with this device, or with the slave device, with the EEPROM considered slave, regarding to the master, which is the MCU. After we open the channel, then we need to send the address of where we want to store, or the address of the cell overall, which we know was the cell, the location of where we want to store the data. Okay, so wire dot write. Okay, sorry, here the write will not be capital, small. Okay, now we write what? Okay, we will write the cell address, but this cell address we should send it as integer, and also we need to shift it because this EEPROM, this device, has two addresses, okay, left and right. So we need to take the first one, we shift it right by 8 places. Okay, then let's copy this to make it fast. Then we take the second address, we take n bit with 0xFF. Okay, with this we access the location of the device, or the location of the EEPROM, which, because maybe you will connect more than one, then we, inside this EEPROM, we go to a specific cell from these two commands, or these two addresses. After this, we will write our data. So wire dot write. Now we will send our data, which is the last key here. After we write the data, what we have more? Done. Then we end the transmission. Wire.end transmission. Thank you very much. We finish with EEPROM, then we go out. But I notice here, because this writing procedure takes some time. It's not like you just retrieve, you write, you need, because this is EEPROM is electrically erased ROM, so it takes some time to write. So it's recommended to add some small delay here, about 5 milliseconds. Okay, that's all. Okay, yeah, that's all for the writing. First, we select which EEPROM we want by using the EEPROM address. Then we go to the cell inside the EEPROM. We send our data that we want to store it. Then we say thank you, end the transmission. Then we add some delay to make our data stable. Okay, let's check if everything goes okay. Okay, done. Very good. So now let's call this function to store this data inside the EEPROM. How will you call this function? Okay. To call this function, let's say here we already print it out. Let's say we call it here. To call this function, we simply just use the name. Okay, EEPROM write, and then we send the parameter and semicolon. The parameter, which parameter we need? We need EEPROM address. EEPROM address is this. Okay, now we need the cell address, which again we say this EEPROM the current EEPROM supports from 0 all the way to 327, I guess 67 bytes or location. Okay, so here we send which location. Let's say I want to store in location number 0 in cell number 0. This is for location 0. Then what I want to send, which data I want to send. For here, for sure, I want to send my frequencies. Okay, but for sure, this is only one what they call one cell, so I cannot store all the array. So I can send only one element, other element 2, element 4, element 1, etc. So to store all of them, we need again to go through all the array, and we store them one by one in a sequence of addresses or sequence of cells inside the EEPROM. To do so, I will use again for integer, so it should be here, for integer address, start from 0, address is less than, because here we have only 10 elements, so I will go for short less than 10, and address plus plus, then I will put this inside the loop. So now for sure this one will be same, the EEPROM address overall definitely will be same, but here will be some changes. Here I will not go randomly, but I will follow the address. Okay, I will follow the address one by one, start from 0 to 9, less than 10. Here I will not again go like any of them, but I'll follow the address again. So in the address 0, store my frequency of 0, which is 132. In the next one, store the next one, etc. Okay, and in order to see what happened, it's better to add some what I call some comments, not comment, but print out some comment to the serial, so I know what is happening. Okay, so let's say serial dot print frequency number let's say frequency number, only frequency number. Then we need another serial dot print and here let's print the frequency. Let's print this. Okay, so the frequency number is let's say is, let's copy this, make it fast. It is stored in address, and then let's take this here, we take only the address. So after it will be stored, then it will print out the frequency number which is which one of them, is stored in address or in address number, and I guess this one is better to be print line. Okay, I guess we're ready with the EEPROM, right? Let's go ahead and test it out. Why? Has defined broken. Oh, no need equal. Yes. Okay, uploading. Good, 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 good. Okay. Beautiful. Okay, so you can see here. But why? See, something happened. Something happened. This one. No, it's correct. It's correct. It's correct, but I guess we need to add some, so we will not be confused. I guess we need to add print line here. No, what's the last one we do? Yeah, I guess here. We need to add serial dot print line and also let's add some delay. So we can understand what's happened. Let's say 3 seconds. And also let's add serial dot print line. Now actually we are storing the frequencies list in the external EEPROM. Okay, let's see how it goes this way. Upload. Okay. Good. IVR do. Thank you. Good. Okay. So I can see here these are frequencies, and beautiful. Now storing the frequency list in the EEPROM, and here we go. So now the frequency number 132, which is the first one, stored in the address number 0 to 127, address 1, etc., all the way to 237, stored in address number 9. So now, after we store it, now we want to retrieve it back. Okay, so to retrieve back, let's add another function. We say this function is to read the EEPROM cells. Okay, since we are reading the cells or reading the locations of the EEPROM, so the function definitely it will return. So it will not be void anymore, but it will return what? As we know, this EEPROM is stored bytes, and even when we store here, we stored a byte. So it will return what? Definitely, it will return a sorry, it will it will it will return byte. Now let's choose name EEPROM read, and let's see which parameter we need here. Okay, to read from the EEPROM, again, the first thing we need is what? Same. is the EEPROM main address. What else we need? For sure, we need the cell address. Okay, we need the main EEPROM address so we can access to the EEPROM. Then we need the cell address so we can access to the cell inside the main EEPROM. So this function will retrieve the data and send it back to us. What else we need? Nothing. No need data, because this data we will retrieve from the EEPROM itself. Okay. So how we start this? Again, same. We start the transmission, or we start talking to the EEPROM by establishing the channel first, which is start by wire.begin the transmission. And for sure, how to begin the transmission? With the slave main address. Okay. After we open the transmission, we open the channel, then again we will go to that cell address. Okay, we go to wire.write, or do you know what? Let me copy this because it's definitely the same. Okay, we will go to that cell after we establishing the channel with the slave. Then what we will do? We will just end the transmission. Okay. Wire dot and transmission. After we end the transmission, because we already access to the main chip or main EEPROM, we go to that location, then we close it nice. From after we end the transmission, then we will request now. Now we will request wire dot request from we will request from what? From here. Okay, here it's just to access the cell. Then we request from this, we're using the same main EEPROM address, but now we request what? This request function needs two parameters. The first one is the main address, the second one is how many bytes we need. We need only 1 byte. Sorry, this is not here. Should be here. Request from. Good. Now we request from this. After we request, we start the transmission. We request. Now what? Definitely the slave will return us, will respond us or acknowledge us with the data that's stored in this EEPROM regarding to this address. So we say if there is a response, wire is response, there is a response available. If available, what we will do? We will read the data. Wire dot read. But when we read this data, we store it where? So we need a storage, we need a variable. So we define here byte read data. Okay, and this read data will be taking the return data from the EEPROM cell. Then we return the read data. Okay, that's all. Let's check if we make any mistakes. Beautiful. Okay, again, we need these two parameters, just the main address and the sub address or the cell address. First, we need to begin the transmission to select which cell we are aiming to, we are targeting. We end the transmission, then we request, okay, from here, read 1 byte from this place or from this cell. Then whenever it is available, because it's serial, you know, serial, so it will take time to read the data. Whenever it's open or available, please read 1 byte and store it in the read data variable. Then after finish, return this data to me. Okay, now how I can use this function to read is very simple. I just use let's say this is the end, so here let's say now I am retrieving the data back. Okay, to retrieve the data back, we just use the same name to call back the function. And again, this function, it takes two parameters. The first parameter is what? Is the address, EEPROM address, which is this. EEPROM, okay, we take EEPROM address. Then what? What's the second parameter? Is the cell address. So the cell address could be, because now here, because now we already store the data from address of 0 to 10, so it could be any number from 0 to 10. Again, could be 1, 2, or 3, or even 10. Okay, so from here, this function will return the data. So if we have, let's say, byte x equal to this one, now x will take the data that's stored in cell number 3 of this EEPROM. Okay, but now I have actually a group of datas, not only one. So again, I will loop back again through all the locations from 0 to 10 to retrieve back my data. So again, for integer address equal to 0, address is less than 10, address plus plus. Okay, so from here, what I want to do, this one for sure it will be fixed, but here will be following the address. Okay, so now let's add some, again, we print out something on the serial. We say serial.print print what? The address and then serial the address. Okay, so I print this address. Oh, sorry. The address this serial.print is return this. So this one I will just print it, serial.print line, print this. Yes, beautiful. Okay, so this one will bring like the address 0 is written, blah blah blah. Okay, let's try. Upload. Okay, upload. Thank you very much. Let's try now. Okay, so this is my addresses now. Oh, sorry. Beautiful. Oh, written 0 0 0 0 0. Why? Why? Again. So our mistake is we have, well, just now we have been initialize our library. Okay, so 132.0.127.1, and here is it. So now if we do a small test, we are not going to write anymore. Storing, we are not storing. Let's command this and this all. So now we will only retrieve. Let's try. So now we will only retrieve, we should retrieve the same data. Okay, done, thank you. Let's work. And yes, this is the one. Yes, here we go. So you can see, even though we are not stored anymore because we already done for once, then we can see we have retrieved exactly the same data. Okay, so I guess with this we have learned how to store and read data from the EEPROM, and also we have learned from this very big fat mistake that we forgot to initiate or initialize our library, that we took some time of troubleshooting, and at the end of the day we just figured out this small issue, and everything okay now, everything is working. And this is the main two functions for this tutorial, is how to write and read from the EEPROM. And next tutorial we will learn how to fabricate an update function, where an update we will not directly write, because this write will consume a lot of cycles from the EEPROM. So we will learn how to do the update, which it will be read first. If not match, only will be write. Otherwise, we just skip. Okay. So thank you very much. I hope this tutorial is useful for you and for me also. So I will not forget to leave my library without initializing. So thank you very much, and see you soon for the next tutorial.